I will like to prove this relationship using mathematical induction. So the steps will be first trying to see whether this is true for n is equal to 1. Then assuming if that is true, then we will assume that when n is equal to k, the relationship is true. And using that assumption, we will see if we can show that the relationship is true when n is equal to k plus 1. If we can do that, we will have proved it using mathematical induction. So first, when n is equal to 1, left hand side here is, this one is 1, so 5 times 1 is 5, and right hand side n is equal to 1, so basically r is 1 and n is 1, so just 1 there for the left hand side. And for right hand side, 5 over 2 times 1, 1 plus 1, so that's 2, so it's 5 basically. So left hand side is equal to right hand side for n is equal to 1. Now we will assume that the relationship is true for n is equal to k. So left hand side becomes 5 plus, when r is equal to 2, that's 10, when r is equal to 3, that's 15, and so on. So 5k here left hand side, and right hand side is 5 over 2 k plus 1. We are assuming that this is true. Now we will see what happens when n is equal to k plus 1. First let's see what's the left hand side. So that's 5 plus 10 plus 15 plus up to 5k plus, since it's k plus 1, so it will go to the next one like that. Now this one, our assumption is this one is equal to this one, because for n is equal to k the relationship is true. So we will, instead of writing the series, we will write the left hand side there, right hand side there. So k plus 1 there, and then this one is 5k plus 1. So basically this one is the right hand side for n is equal to k, and this is, we can write instead of the relationship, instead of the series here, since this much is actually n is equal to k, and then this one is the k plus 1th term. So that's there. And now if we try to do this one, so basically this is 5k plus 1, so I will write 5k plus 1 here as common, and it becomes k over 2 plus 1, so that's 5k plus 1, and then k plus 2 over 2, or it is 5 over 2 k plus 1 and then k plus 2. So this is the left hand side for n is equal to k plus 1. So what is the right hand side when n is equal to k plus 1? So right hand side is 5 over 2, that's, first I will write in terms of n, so that's n plus 1 there, as we saw the right hand side there. So here when n is equal to k plus 1, it becomes k plus 1 here, and this is k plus 1 plus 1, so basically 5 over 2 k plus 1 k plus 2. So this is the left hand side, which is here, this one. So basically we have shown that the relationship is true for n is equal to k plus 1, with the assumption that it is true for n is equal to k, and of course first we showed it that it's true for n is equal to 1. So it is proved, the relationship is proved using mathematical induction, in mathematical induction method.